Welcome, viewers. This video we are looking at some numerical topics. Now we are still on that simple stress and strain but the question on the board says bar shown in the figure below, because this is the figure, subjected to a tensile load that 50 kilonewtons. Now we are asked to find the diameter of the middle portion B of this portion if the stress is limited to 130 mega. Of course, you know that mega is nothing but 10 power of 6. Find also the length of the middle portion if the total elongation of the bar is 0.15. That's what we have. So we are given E, which is the modulus of elasticity, is equal to 200 giganewton per meter square. Of course, giga is nothing but 10 to the power. Now, next, we are going to solve this question. Now, we know that sigma, which is our stress, is equal to force over that sigma force or load. Now, from the question, you can see that we're given 130 meganewton per meter square as the limiting what? As the limiting stress of the middle portion. Of course, you can find it here. It's 130 meganewton per meter square. Now, this is equal to 130 meganewton per meter square. Just say times 10 to the power of 6, because we are having mega to the 10 to the power of 6 all over area, which is I. Now, of course, we know that our P is equal to our stress. Here we have P to be 50 kilonewton. Of course, kilonewton. So this equation now becomes 130 times 10 to the power of 6, which is the stress of the middle portion. It will be equal to 50 times 1000 all over what? All over pi 4. What we have. So next we are going to be looking for the value of B. Of course, we are asked to find the diameter of the middle portion. To do that, first thing first, we are going to cross multiply. Cross multiply, we have 50 1000 equal to what? Equal to 130 10 to the power of 6 pi 4. So this is what we have. So next, what can we do? Of course, we can divide both sides by this way. Do that. This, what will I do? I will open that bracket. If I open this bracket, I will have 50 times 1000 equal to 130 times 10 to the power of 6 pi, that is multiplied by pi, multiplied by this square. This is what I have. So next I can cross multiply. If I cross multiply, I will have 50 times 1000 is 4 is equal to 130 times 10 to the power of 6 times pi times square. This is what I have. So next, I'm going to be dividing both sides by 130 times 10 to the power of 6 multiplied by 5. If I do that, I'm going to be having 130 to the power of 6 multiplied by 5. Here also I have 130 multiplied by 5. Of course, you know that 130 times 10 to the power of 6 will go with 130 times 10 to the power of 6. 5 will go with 5. So I'll be left with 50 times 10 1000 rather multiplied by all over 130 times 10 power of 6 multiplied by 5. This will be equal to Now, of course, I can take the square root of both sides. If I take the square root of both sides, of course, you know that this square, so I'll be having d is equal to the square root what 50 1,000 or all over 130 n to the power of 6 x. I'll be putting here and for answer. Now, what do we have? Take the square root of this. Our diameter will be equal to 0. What? It will be equal to 0.021. So the diameter, that is the diameter of the middle section here, but hence, you can say that hence, of the middle section 0.021, and this is what we have. So next, we are going to be looking for x, that is the length of this place. Of course, we don't know the length. We just call that place to be x. We are going to be looking for the length. Before we do that, we are going to be looking for the stress at the end portion. We are going to be finding the stress at the end portion. Find the stress at the end portion. Let the stress at the end portion be equal to sigma prime. Let the stress at the end portion be equal to sigma prime. Of course, we know that sigma is equal to what? Equal to P all over A. But in this case, we are going to be working with the diameter of the end section. Of course, we know that their diameter are the same, 40. So this is equal to 50 times 1,000 is our weight, or which is our force from the question, all over area, which is I by 4, into what? Into what? Into B. Into our diameter. Now we have 40 diameter here. We are going to be converting 40 cos 40 millimeter to meter. To convert 40 millimeter to meter, we are going to have 0.4 meter. So here we are going to have 0.04 square. So if we look for, if we calculate that, our sigma prime, which is our stress at the end portion, will be nothing but 39. We have 39, 9.9 10 to the power of 6 newtons per watt. So this is our stress at the end portion. Now we are going to be looking at two formulas here. In this first formula, we are going to be looking at elongation of the end portion. Elongation of the end. Now the elongation of the end portion, sigma prime, which is what? The stress at the end portion, multiplied by what? Multiplied by 0.25 minus x all over e. So we have sigma equal to sigma prime multiplied by 0.25 minus x all over. If you want to get this formula, is of course a formula for the elongation of the end portion. Now, how do we arrive at this formula? We know that elongation, our change in length, is equal to what? Equal to P over what? Now, we also know that stress, sigma, is equal to what? Equals to P all over A. This stress, that is sigma. Now, if sigma is equal to P all over A, you can replace sigma for P all over A here. If you do that, it implies that what? Our change in length is equal to what? Sigma L over what? And of course, this is what we have here. So this can be sigma prime, while we have L to be the length. Now, for the length here, we know that we are looking for the elongation of the end portion. And so what we are going to do is that we are going to be taking out the middle portion. So the total length of this bar is 0.25 meter if it is converted to meter minus middle portion. So we are going to have the length of the end portion. So that's why this 0.25 minus x because it's representing length because of the two portions. So this is what we have here all over E, which is our modulus of elasticity. So with nothing, this is what we have as our elongation of the end portion. Next, we are going to be looking at the elongation of the middle portion. Elongation Now, the elongation of the middle portion is still the same thing as the elongation of the end portion because we are having what? We are having our sigma, but not this sigma because initially from the question we have been given the stress of the middle portion. So for here, we are going to be having sigma, which is this 130 meganewton per meter square, multiplying what? We don't know the length, so it will be x. We are dealing with the middle portion now, so we have x all over what? All over E. Of course, we know that sigma here is representing E all over A, so our relationship still remains the same. So next, I'm going to be cleaning up here, and we are going to be adding these two elongations to get our total. In order to get x, of course, what we are looking for is x, which is the length. We're going to use the formula that says the change in elongation, that's the total elongation of this bar, will be equal to the elongation of the end portion plus the middle portion. Of course, this is what we have here. So the L is our change, this is our total elongation, 0.15 millimeter. Of course, before we proceed, we can convert this to meter. Convert this to meter, we are going to be dividing it by 1,000. So if we divide 0.15 by 1,000, we are going to have 0.00015. So we have 0.00015 to be equal to, here we have elongation of the end portion. Sigma prime we calculated earlier to be 39. Calculate sigma prime to be 39.79 10 to the power 6. Have it multiplying bracket of 0.25 minus x all over our modulus elasticity, 200 giganewton, 100 what plus what do we have? We have our sigma, which is what? The stress at the middle portion. It was given to us as 130 meganewton per meter square. We have 130 meganewton at multiplying x times x all over what? All over what we have. Of course, we can take the LCM of this side. We can take the LCM here. We're having 0.00015 equal to 39.79 and 10 to the power of 6 multiplied by 0.25 minus x plus 130. We have 130 times 10 to the power of 6 multiplied by x all over 100. Now this is what we have. Next, what are we going to do? We are going to be cross multiplying. Of course, if we cross multiply, we are going to have 0.00015 times 100 times 10 to the power 9 is equal to what we have here. Of course, we are first multiplying. This is multiplying here. We have just one here. So to first multiply, we have 39.79 times 10 after first multiplying. This equation, of course, we can find the value of x. We have x here. We have x here. So what do we do? We're just going to multiply. We clear this bracket first. After clearing this bracket, add, because we're going to have x here and x here. You add the value of x here. We're going to have a value. We are going to divide that value. Of course, we are going to divide by the coefficient of x. Divide by the coefficient of x, you're going to have the value of x. Very simple, just by clearing this bracket, adding the value of x, and dividing both sides by the coefficient of x. The value of x. Do that, you're going to have x, which is the length now of the middle portion, equal to nothing but what? 0.2. X will be equal to 0. Very simple, using your calculator, you can add that in just seconds. So from here, you can see that we have successfully found the diameter of the middle section and also the length of this. Thank you for watching. Stay tuned for more numerical problems. Have any challenge on all the solvings we have done previously? Type it in the comment